Alright, time for another draftphysics.com, debatephysics.com also, video presentation, and such. So, doing my, whatever, bookkeeping, I don't know, yeah, whatever, the cleaning up, and we will talk about energy and this. I don't understand what you think it is, I guess you could say, at all. And for me it's kind of obvious what it is, and it's kind of mechanical and simple, and it's not a magical word at all. It just has to do with a unit, an amount of stuff in the universe, stuff versus non-stuff, no waves involved, and stuff hits another piece of stuff, and a little piece of stuff has a little bit of energy, say, and a big piece of stuff can require a lot of energy to move it. So a little thing can hit a big thing, and depending on how fast it's going, it's got its mass, its stuffness, and then it's got a certain amount of velocity, and you just calculate the mass and the velocity and conserve that, and pretty much that's all there is to it. There's a bit of force and there's a bit of matter, and the two make an equal contribution to the outcome of storing or holding or keeping movement in the universe. So there's an amount of movement. I mean, look, the simple argument I'm making is that the universe is just made out of little BBs of force that all have a direction and go in straight lines, and the matter is inside this field, this container of BBs, and the BBs stick to the pieces of matter depending on how they're moving. The simple rule would be is if something's already moving, that is, a BB's already stuck to it going this way, and another BB hits it this way, they don't both stick, they both reflect. And so they're free again. They're back in the system of BBs. But if nothing else is going this way and something hits this way, then it keeps adding speed in that direction. So that's the simple concept. Anyway, it works for me. The universe seems perfectly understandable. I don't see any experiment or any data that says it can't be that way. Any derivative, any perversion, any interpretation of what happens in the real world that includes something else, I'm sorry, I don't see it. Alright, but anyway, so this was a Ian Gosling video I didn't play, because, well, even the title's stupid. Who cares about this pronunciation crapola? I mean, I can get you people on so many things that you can't pronounce correctly. Or you English people. So what's the point of it? There's no point. Anyway, leave us play the video, I guess, right? Is there something else I have to do? I guess not. I'll draw later.
Just a quick one, I promise, in subsequent.
So who cares? Quick, all this stuff. You're supposed to make arguments, and they're supposed to be relevant to the counter. They're supposed to counter an argument. All right. So, one of the arguments I've made about energy, just throw this in, is that there's this whole conservation thing. So you're telling me, aggressively telling me, I have to believe. I'm an idiot too. I'm a flat earther if I don't believe your story of reality. All right, so I have an object, okay, and we'll just say it has one amount of mass, okay, it doesn't matter what it is, and all I'm going to do is I'm going to give it a velocity, and presumably in space, in a frictionless environment. And all I'm going to do is through the adhesion of the objects, I'm just going to add another one to it. So I'm going to stick another hunk of matter to it. All right. It's not going to have any real force, okay? They're going to stick because of a tiny little interaction that's going to take place. And I'm going to convert this one into 2 units of mass. All right, and then it's going to go off in some, all right, with exactly 1/2 the velocity, because I've doubled the mass. And your theory is, okay, is that this has 2x, okay, the energy of this. This is only 1x the energy. So somehow through this process, I destroyed half of the momentum or the velocity. We're not really changing anything in the matter, we're just adding matter. And so the velocity is the only relevant thing. And it's perfectly consistent. I mean, Newton would say, yes, you know, if you want to double something's speed, you double the force, or double the mass if you want to have the mass. Anyway, so, but your theory, you're saying that I'm an idiot if I don't believe you, okay, that somehow I have exactly the same momentum, so everything worked out fine from my understanding. Okay, you have an arrow of force, and you have arrows of what you could call the mass. All right, they're going to add up to your energy. So, you know, you just add up the bits. You have to have an element of matter to be able to collect the force. You have to have a bucket to put the water in. Okay, and it's really just about how much water you can hold, depends on how much bucket you have to an extent. So this is the energy going in is this amount. And obviously when it's pushing one object, it goes at a speed. So let's just say the force is this. All right. And now you apply it to one mass, and you can understand that now, say this had a little tiny mass or whatever it had, you've combined those, and now this arrow is proportionally a little less than what this arrow was in terms of speed, because now it's pushing an object. And then you double the amount of the weight that you're pushing, then obviously you have to reduce, right, the amount of velocity, because the pusher only has so much push. And if he has to push two objects, that's going to take twice the energy it took to push the one object. So, you know, momentum works, completely explains why this happens. And then, but you're saying that no, the real story is this had an amount of energy in the universe. The universe had a certain amount of energy in it here, and that it has less here. When this object's created, I've lost energy in the universe. So this has 100 joules. We'll just use those as numbers. And this has 200. Oops. Wrong way. This has 50. So we lost half the energy. And then you say, well, you lost it because it made sounds, or, you know, it smashed on a track, or it did something to destroy half the energy. So even though I can make the connection between those two objects, the internal doesn't change anything internally. They combine readily. Okay. You're saying half the energy was lost, but you're not going to show me anything. You're not going to show me, you're not going to take its temperature, you're not going to show me the pieces flying off. And besides that, what you're not going to explain to me, okay, is how I can have the same momentum. That is, everything's working just fine momentum-wise. The universe has the same momentum energy, I guess ME we'll call that. We have the same momentum energy here that we had over here, and somehow I banged into things, I bent things, or I made heat, or I did something else, and yet I didn't use any momentum. So I have the same amount of momentum, which is considered by some to be at least a kind of energy. You know, I have the same amount of momentum, and yet you're saying I banged into things and I bent them. I did work. So somehow I did work without using any momentum. Work? Well, I did work. Work. Anyway, work. So, you know, it's not, you should concede that, yeah, well, that does seem a little strange that I could lose half the energy and I can't explain where it went, because if I try to explain where it went, I have to explain how there was an exchange. You know, the energy is going this way, right? If I'm creating heat or something else, it just means that I'm sending bits of energy in some other way. If if I use it to bend metal, then I'm using it to move atoms in ways that I'm not going to get this vector back. Okay, it means the vector is lost going some other crazy way, and then it just leaves this heat. So, I mean, every kind of sound, no matter what I try to create as a loss in space, I'm not going to have any sound problem. There's no way I can explain how I lost it. That is, it went in another direction. You know, especially heat. Heat goes in all these directions. It's little vectors of stuff moving, little pieces flying off. A little piece flying off, that could be a good example. I mean, if you claim a little piece flew off in a direction, how could I put energy into that, give it momentum, and then still have half my momentum? I mean, all my momentum. I mean, how can I give away any of the momentum and still have the momentum? So, I mean, theoretically, it doesn't make any sense. So, Newton, Descartes, and Galileo would all say, this makes perfect sense. No problems, okay? There's no magical, this doesn't happen. There's no twice the energy here and, you know, half the energy over here. There's the same energy going in, same energy out. No problems. You know, and this half is it's actually a little less. Okay, so let's just understand that, yes, we are conceding there's a little bit of a problem combining the two objects. You do lose a little bit of energy, but it's a tiny amount. So, I mean, it's just one example, and you just keep ignoring the example. You don't answer the question. I mean, how can I do work, bend metal, create sounds, create sparks, create heat, and keep all of my momentum? It's like saying a hammer can hit something, and yet the hammer gains back all the energy it had. You know, no, I can't do that. Alright, wasn't perfect, but it'll have to do. Alright, so this I will try turning it around. Let's see, so I have to go counterclockwise. I believe that would be correct. Okay, doesn't look correct yet. Ah, there it is. Okay, he can't do it. Yeah, he knows all these truths, but he can't figure out how to rotate a video. Anyway. Continuing.
To some thoughts, part one. Exponential, not exponential.
Exponential, not exponential. Okay, fine. Yeah, it's, you know. Jesus. Obviously, I'm not going to change how I speak, so I'm really not worried about it. So, tough luck. Tough ruck, okay? If I said ruck instead of rock, instead of luck, I mean a lot. Oh, damn it. It would be your tough ruck.
Exponential, Gary, it's very important.
No, it isn't. No, it's very unimportant. It's insanely unimportant. Exponential versus exponential. I mean, frankly, I couldn't tell the difference when you said the two words. Okay. That's how my brain works. Just turned them right into the same exact. You just said the same word twice. Didn't mean a damn thing to me.
Displacement along here, going up.
The displacement. Okay, so this is, again, I've already made this argument. Okay, this is called cause and effect. Okay, so he's telling me I have to multiply the cause times the effect. And I'm arguing that I don't think there's any place in physics you could make that rational. That there's any place in physics where it would ever make sense to multiply a cause times the effect. Its effect. It just never could be useful.
With a spring, the force required up here going up. One little bit of displacement. We've got two factors to multiply together.
Why? Why would I do that? Why? Why would I multiply a cause times its direct effect? What possible information could I glean from such a thing? There'd be no reason. So this is just saying what Newton said. Okay, the force directly affects the outcome in terms of your velocity. So this relationship could be just the same as just having velocity put on one scale and force on the other scale, and just say that there's a correlation that's kind of direct. You want double the velocity, you just double the force. no reason to multiply them times each other. I mean, there's just no sensible reason. Now, if you're going to multiply a mass times a velocity, that makes sense because the mass is the bucket and the velocity is the thing in the bucket, the amount in the bucket. Those are both causes of the effect called energy. So, and you have to have both constituents to have energy. So that makes sense. This doesn't make any sense at all. I mean, the outcome is the distance, or in the case of one equation, that's what you're doing. So again, it's why should I think that is rational mathematics? So you go to the trouble to draw your little chart, but I mean, what does your little chart mean? Why would somebody draw this chart? Why didn't Newton draw this chart if this chart was some sort of rational chart to draw? Cause over effect. So he's sitting there telling us, telling me, telling you, telling the world, okay, that energy. So the idea of something moving, a mass with motion, okay, these two components. All right, so I should say that the force, okay, whatever causes this to move, which is the same as the velocity, you could argue. So I put that on this chart and sit there and say somehow I'm going to multiply these two things by each other. So that makes sense, right? Mass and velocity will equal your energy, or your momentum is what I call it, right? You call it. I call it momentum, you call it something else. All right. You call energy something else. I don't know what it is, but some magical, cause times effect. Okay, so whether we are measuring distance, whether you put distance down here or you put how much you compress a spring, they're all going to be the same. It's the same completely linear relationship, twice the force, twice the distance. So twice the velocity, twice the spring compression. So, but why would I multiply the cause times the effect? I mean, what do I get by doing that? I get your silly squared idea of a universe where everything's squared. But why? Why do I believe that? Why would I believe it? Does it work in space? Is it conservational? So I just demonstrated that it isn't conservational when you use it. It breaks simple experiments. Just doubling something's mass, somehow I lost half the energy, and if I half its mass, I'll gain more energy by some magical theory of yours. I don't think I will. All right.
2 of the displacement and 2 of the force. 2 times 2 is 4. But as we go to the 4, we'll double the displacement. It's now 4 times 4. I've been over this. 4 times...
Yeah, you've been over it. And it doesn't make any sense. It doesn't take 4 times the work to compress a spring twice as much. I don't have to use 4 times the energy to do it. I just have to put 2 objects on a scale. I do 2 units of energy. So again, you keep saying it's the truth, and I keep saying, how the fuck can it possibly be the truth? You're overtly telling me there's free energy. You're telling me I believe in free energy, because why the hell couldn't I exploit that? The very fact that you're saying it's 4 times the energy, even though I only put 2 units of work in. How can I have 4 units of energy and I only did 2 units of work? It's ridiculous on its face, and you just keep preaching it as if, well, how could I dare violate this marvelous theory of yours, or criticize it, or say that doesn't make any fucking sense. Well, it doesn't make any fucking sense. It doesn't make any fucking sense for you to draw these numbers on these idiotic 2 squares is 4, 1 square is 2. I mean, you can't even get that right? He's got 1 unit is a 2. And then 3 units is a 4, and then 6 units is a 6. Well, that's all he got right. I mean, it's too silly. Can't even write it proportionally on the piece of paper.
4 is 16. 6 times 6 is 36. So it's going up at the square. This is the exponential line. It's very important. Lots of things like...
Like what? Like what? Why is it very important to multiply a cause times its direct effect? What could that possibly prove or demonstrate? You're multiplying it by itself for no good reason.
Energy stored in the spring. Energy.
Yes, you keep saying it, you'll never show it. Okay, so go ahead, show me, somehow you capitalizing on this idea that you do 2 units of work and you get 4 times the energy. Show me that I can just lift something onto a scale twice, the same unit of mass, and then that compression of that scale will have the energy, stored of those 2 units of work will somehow equal 4 units of energy.
Stored in a capacitor and the kinetic energy formula. Just to explain it.
Some more nonsense, okay? I mean, you want to say that's what it stores? It stores by the square term. You can say it all you want. I'd say bullshit. The fact that you can make up fake joules doesn't mean you can't make up fake watts just as easily. Yes, I'm saying it's all bullshit, okay? It won't do any real work in the world.
In simple terms, there's 2 factors you've got to multiply together. That's
Why? What theory is there for multiplying those 2 factors? A force times its result, the resultant displacement. Why would I do that? It isn't a cause and a cause. The effect is not a cause. You have to have 2 causes and multiply them to create an effect.
You get this square term, exponential growth. Right.
So he's conceding you get exponential growth. So that's right. So I get smaller and smaller masses. I just get more preposterously insane amounts of extra energy. I can just make insane amounts of free energy by your theory, by just cutting a mass in half, cutting a mass in half, cutting a mass in half. I just keep making energy with each outcome.
Misappropriation of words. Momentum's one of your big ones. And that ties into a straw man, because you say, well...
It ties into a straw man. I'm just saying, what does it tie in for you? You have a word called momentum. What the fuck is it if it isn't energy? So it isn't a description of movement in the universe, mass moving. What the fuck is it a description of? Okay, so you tell me. What the fuck is momentum if it isn't energy? What the hell does it do? What is it? How the fuck do I conceptualize this thing called momentum?
We've got to conserve the momentum when the way you're using the term is not applicable. Momentum.
Oh, you don't have to conserve momentum, is what he's saying. Somehow it's not applicable. Applicable. But anyway, of course it is. I can apply the word to the concept of what was known, again, by Newton, Descartes, and Galileo, all guys who got right answers. They all understood it the same way I'm arguing. So how did their misconceptions lead to anything they predicted incorrectly? So they didn't make any incorrect predictions, even though they had a completely wrong answer to what the real energy in the universe was. I mean, please, too silly.
It's not about energy. If you say it is, think of a new word, come up with a new word.
No, I don't have to do any of that. The concept is clear. The universe has this stuff in it called energy. That has to be conserved. And in my opinion, there's absolutely no difference between momentum and energy. So yes, they're interchangeable words. That's motion and mass in the universe. Motion and mass. You're saying I have to 1/2 and square. These aren't real things. The half isn't real. The square isn't real. That's not a substance in the universe. That's not an event in the universe. There's no 1/2 in the universe. There's no squared in the universe. So show me a material reason why I should believe there should be a square there. What's the material cause? Again, where's the material cause? And I would argue that things like levers prove there's no such thing. There is no material cause. There's no good cause. There's no reason to believe it. Levers prove it's nonsense. Because I can do the conversion of momentum with a lever. I can convert momentum in a heavy object into momentum in a light object. I can make a 5-ton train going 10 miles an hour out of a 10-ton train going 5 miles an hour. So even though the 10-ton train, by your theory, has half the energy, it can produce a 5-ton train, okay, So, fuck you. Until you can show some real experiment that shows these things don't happen. So again, do a lever experiment. I mean, one, like Brozos or something. Make a lever, a seesaw. Show that if I put the two mass going 1/2 the velocity, 1 unit of distance from the fulcrum, and it won't shoot out the half mass at twice the velocity. Show that it don't happen. But till you do that experiment, I'm not convinced. There's no theoretical, reasonable, rational, logical reason to believe in this shit. None. You don't have anything you can describe. You can't show me any experiment. You can contrive one.
In physics, momentum, nothing to do with energy.
Okay, so then you might as well say then in physics has nothing to do with physics. Fine. That's my accusation, is that your physics is a religion. It doesn't have anything to do with reality, logic, reasoning, any of those things. Those things are all shit to you because all you give a fuck about is exponentials. All you want to do is square shit for no good reason.
So if you're going to use that word, forget the energy bit, or come up with a new word.
No, I don't have to do any of that. Fuck you. My obligation is to describe the truth as honestly and best and as articulately as I can, and I've drawn the energy equals momentum, weight, pressure, heat, every single thing that you think is a derivative of it, some sort of magical component of energy. These versions of energy, as you call them. There's no version of energy. There's just mass moving. There's nothing else anywhere in the universe. To get movement, you have to exploit something that's moving. Nuclear power is made out of the pressure, the amount of little force bits collected by electrons and protons.
Because nobody's going to talk to you. No physicist will talk to you.
Well, whatever. You know all the physicists. You know what everybody else is as big a liar and shyster and conniver and creepy, shitty, charactered human as you are. I won't assume that all the physicists are that stupid and dishonest. And that if a few of them actually heard the counter arguments, they might say, hey, you know what? You got a point there. It's unfortunate that, 300 years later, we're actually re-examining the arguments made back in Newton's day when Leibniz was basically proven to be kind of incredible. So let's again remember, you lost this argument 350 years ago when Newton was alive. And then somehow after Newton died, you started slandering the fuck out of him and deciding to all become new Leibniz fairies. That's not my bad, and it's not even. Well, it's the bad of physics. It's a shitty science because the science doesn't have any respect for actually proving a claim. They just like to make shit up like religious kooks. So, like medicine men, they just tell the people, they know the real trick, but they just tell them it's a mystical thing. I talk to God, so if you want any answers, you have to come to me because I can talk to God. Some kind of bullshit like that.
While
you're all God whisperers. The magic squared exponential God.
Appropriating their words.
No, you're appropriating them, okay? Your little cult stole all of the credibility of physics. You broke it 300 years ago, and you're just an advocate for the breakers.
Now, here's a good one. The Mythbusters. Not ignored it. You say.
Yeah, you have, okay? To say that clay, if I compress a piece of clay a certain amount, it has potential energy still in it or something would be ridiculous. But to say that somehow it's harder to push clay, the less clay that's left is somehow harder to push than the first bit of clay, frankly, is a ridiculous argument.
Explain it. When they drop that core sample of plasticine or clay on the pendulum, they double the speed, compress the clay cylinder twice as much, and you say, look, it should have been 4 times as much.
Yeah, so I wonder why it cut off there. Yes, that's what I say, and your counter argument is exactly what you put in this video. Moronic. Alright, so let's see. There are some comments here. Comments have been kind of lacking, so too bad. Alright, Bruce Lufty. We saw him the other day. You talk about misappropriation of words, then use the word exponential to describe a curve that is only parabolic. Right, it's not exponentially growing. It's actually, the curve has to be parabolic to be exponential. That's the funny part. The straight line is linear. Anyway, exponential is where input is in the exponent of the output, like y equals 2 to x to the x amount, not x to the 2 amount. Okay. This applies to things like population growth versus spread and monetary inflation. Yes, if inflation was the same all the time. Anything where the rate of growth is proportional to the current size. Okay, so let's see if he says more. Parabolic growth, like the energy of a falling mass, means the rate of growth increases only linearly. The speed of the falling mass increases linearly over time. 9.8 meters per second. Why do you have the squared in here? There's just no reason to do that. So its energy increases parabolically over time, which frankly is going to get you into trouble too. But why does it, why the second squared? There's just absolutely no reason for it. They just, even people arguing against him misappropriating words. I mean, it's just silly to call a rate squared. The rate isn't squared. There's nothing to square here. It's 9.8 meters per second. Newton didn't say 9.8 meters per second squared because there's no reason to say squared. There's no reason to square any number here. It's only a rate, 9.8 meters per second. That's it. It's a rate. Yes, you can do it more than 1 second. That's it. You do it in second, then it's 19.6 meters. There's no squared. Whatever. Dear Bruce, you may be correct. The difference is not intentional but lack of understanding. So he's making these videos educating, and he just claims, well, I just don't understand what I'm talking about, but I'll make the video anyway. Interesting. Parabolic means of like a parabola shape. And yet the graph of the spring stored energy gives a straight line. And again, it's not a graph of anything called energy. It's a graph of you multiplying something times itself for absolutely no reason. Multiplying the cause times its effect. Of course, the cause is in the effect. So you're just multiplying the cause times the cause and saying, there, I have an answer. And it's not an answer. It's stupid. No reason to do it. And then he says, by the way, thank you for mentioning the lever test video I made to Gary in his live stream. So, what do we go back to this lever test video that I've already debunked and they don't pay any attention? Okay, fine. Okay, it showed the difference acceleration nicely. No, it didn't. So, again, he can't do the experiments as I described them. They always have to change something and distort it. So he didn't use a balanced lever. He didn't put a counterbalance on the lever. And then claimed, it's a balance. It's clearly not a balance. But it's dismissed with weak excuses. Well, the weak excuses are it's not a balance. So I'll draw that again. But it's not. Okay, the spring has to do work to create the balance. So you're already putting work into the spring. You're already putting force on the spring just to cause it to stay balanced. All right, and that's not good because any added force will have to also be imposed on the same spring. So vaguely, as I remember, spring, and then here's the lever. So he attaches a spring to a lever. Got to do this. Good of you to remember, Gary. I guess we can, yeah, we can undo that. So I should just be able to go back clockwise, right? It looks like it's right. Okay. And then we'll just get rid of it. Fix it and then get rid of it. All right. And so, he puts a 1 mass and then the 2 mass here. And unlike as I suggest, right, if you do this with a real lever, okay, where there's the same lever on both sides, it's a balance, okay, and the argument is it doesn't really matter. So if I put a 2 mass here, all right, I can put a 2 mass here, I can put a 1 mass here, and I can put a half mass out here, and I will get exactly the same movement over here. So whichever one I put here, this won't change at all. Okay, this would move the same, this would move the same, this would move the same with the same energy put in. This will move exactly the same, indicating these all weigh exactly the same amount. Okay, so even though the masses are different, the velocities will be proportionally larger. So, okay, so bigger mass and bigger velocity, and then this one finally has the biggest mass and the smallest v. That'll always work, and it'll always weigh the same, and everything will move the same. So he's saying he did it with this contraption, and he proved this oscillates at some other speed. Okay, it doesn't go twice as fast. The velocity here is not twice the velocity here. Okay, that somehow the same pressure doesn't create the same action. He doesn't conserve the momentum, in other words. So the momentum isn't conserved. When you do the experiment with this and you do the experiment with this with the same force, somehow the momentum isn't conserved. So even though conservation of momentum is preached by physics, he keeps doing experiments attempting to prove there is no conservation of momentum. Now, he won't title his videos that I've proven there's no conservation of momentum, because he's a coward. Okay, and he won't take on Professor Lewin or any of the other professors who are teaching conservation of momentum. He'll just keep doing these experiments where he breaks conservation of momentum, so that's what he does, okay, and then claim he's debunking me. Yeah, okay. I could argue that that's too silly too, right? I'm in the ironic position of defending conventional physics and conservation of momentum. So he says that was a great argument. He won the argument somehow, and I haven't dealt with it, and I didn't explain why it doesn't work. Well, it doesn't work because you have more lever. You didn't put a counterweight on the other side. So then the spring doesn't have to do the lifting of the lever. In your case, the lever's weight has to be divided into the weights of the objects. And obviously their masses, one of them has a much smaller mass, it's going to be able to change the mass of the total lever less. Where the other mass is heavier, it'll change it more. And you just ignored that fact. Okay. Alright, mindless. Yes, the correct terms are quadratic. The relationship are parabolic, the shape of the graph here. So all of this, I couldn't care less about. I'm just trying to figure out why you're multiplying a cause times an effect and telling me that's a rational thing to do. That somehow I'll get a rational answer to any question in the universe by multiplying the cause to a direct effect. There's something that has a direct proportional effect. So something that causes something to happen exactly the amount of the change in the cause. That there would ever be a reason to do that. The relationship between force and displacement is linear. Yes, well, we've all heard that word. The relationship between energy and displacement is quadratic. So this doesn't, force and energy aren't the same thing. So in their opinion, forces can create all kinds of energy. So I can have the same force in, and I can create all kinds of energies out. And it just depends on whether I hit little things and make them go fast, or I hit big things and make them go slow. And to me, there's no logic in this universe they've created. None at all. It's illogical on its face. You don't think it's illogical. I don't know how you're not getting it, but it's completely illogical for you to think you can change the nature of a force and make it weaker or stronger. You can have more octane in your gasoline, based on who you push. You push little things. Your gasoline has 5,000 watts in it. You push big things, your gasoline only has 3 watts. I mean, it doesn't make any sense. Thermal units, whatever you want to use. Alright, I'm not sure if I understand your last sentence, but it seems like you're talking of force versus X plots, which gives you lines, and then you're considering the area under the line. I don't know, his last point was that somehow clay, okay, is harder to compress. The more you compress clay and the more you squeeze toothpaste out of a tube, it's harder to squeeze. No. I mean, we know that, yes, you can't get the last bit of toothpaste out, but I just mean why there's still lots in there. It's really there's no change in the pressure. When half the toothpaste is out of the tube, I can still squeeze toothpaste out of the tube just fine. If you put E versus X directly, then you get a parabolic graph. Well, whatever, who cares? I mean, it's just, like I said, the real point, in my opinion, is what are you multiplying? You're multiplying a cause times its direct effect. And why could that make sense? Sorry about my chair squeaking for unknown reasons. The graph of the spring force against compression shows a straight line, as Mr. Hook tells us. So Mr. Hook tells us basically that you want to double the compression of a spring, just double the weight. And I can double the weight by doing twice the work. So how the fuck could it be 4 times the energy? I mean, Hook didn't say anything about being 4 times the energy. But if you were to plot the energy against the compression, you would see a parabola. Well, whatever. Your chart has the energy represented by the area under the x distance and y force curve, which makes sense because the work equals force times distance. So again, they just keep saying it, and I'll keep saying, well, that's only in certain circumstances. So what's the catch to that statement? Because it doesn't make any sense, right? I mean, again, I do the experiment in space with objects, and the distance things won't roll further or farther or any of this kind of stuff, because I won't be extracting the energy. So the work will be completely consistent over a long period of time. The twice as fast thing is going to just go twice as far, so it's only going to get twice the distance, so it's only going to be doing twice the work. But it's not really doing any work. Is the catch. But anyway, it's just, I mean, obviously in the case of gravity, there's no way distance could make sense, because it's 9.8 meters per second. So again, why do they keep talking about it being 9.8 meters per foot or per inch or per, I mean, that argument alone should just be defeated. There should be no way you can argue that the work gravity does, and let's just be agreed that we can call it work, okay, as a force. It does work on an object, okay, it gives it an object properties, so it's doing work on an object, either opposing its motion or giving its motion, and that it doesn't do that per foot or per inch or per unit of distance. It doesn't do any work per unit of distance. It only does work per units of time. And that's a proven fact. 9.8 meters in the first second, okay, of work done creating a velocity. The velocity is the effect. Okay, the cause is the force, gravity. The effect is 9.8 meters per second. Okay, so in the first second you got 9.8 meters of velocity. In the second you only get another 9.8. Where is there anything squared in here? There's no reason to square anything. There's no reason to measure the distance, because you know when you're going twice the distance, I mean twice as fast, that you're covering distance much quicker. So you're already going 9.8 meters per second, and then it's adding more speed. And in 1 second it does 3 units of distance, in the other second it only does 1 unit of distance. How can I use units of distance to measure how much energy it has? It doesn't make any sense, because it covers more and more units of distance. The longer I let it fall, the more units of distance it covers without doing any work. The force isn't doing any more work to create those extra units of distance. Those are ones for free, because it already created them in the first second. The units of distance are exponentially growing. Fuck. Alright. Work equals force times distance. So again, it doesn't make any sense. You can't apply it to anything gravitation, because it's a lie. It's just overtly a lie. Okay? Twice the time, twice the velocity, twice the weight. You just keep lying. Alright, note that if you sum the linear sequence 1, 3, 5, 7, 9, you get squares. Yeah, why would I do that? So again, what does that demonstrate? Except you don't understand that these numbers of distance are hugely disproportional, and gravity doesn't give disproportional amounts of energy. It gives the same amount of energy per second. So again, why bother? Why bother if physicists, if people interested in physics can't even understand the concept of per second? I mean, they're completely annihilating, blowing it up, turning it into some kind of bizarre thing that somehow per second is a complex idea. That something, a certain thing, a certain amount of something happens per second, and they're turning that into distance. Per foot, per meter. No, it's this per second. Alright, anyway. Gary is very aware of the 1, 3, 5, 7, 9. Yes, I'm very aware that those are not the extra 3. Okay, the 3 minus 1 is 2, right? You got 2 units of distance there. Did you do work to get those distances? No, no work was done. The work was already done by giving you the velocity. So when you got the first 9.8 meters per second, that work adds up to an infinite amount of energy by your theory, because you're going to get an infinite amount of distance out of it eventually. Eventually that extra velocity isn't going away, and it's forever in space. You're not doing any work to get it. Fuck. Sequence popping up whenever we have uniform acceleration, but it's resistant, but is resistant to allow the use of the word squared anywhere. That's certainly not the point of my video. I'm saying, yes, squares bother me as a concept, because there's very few circumstances where it makes any sense, to, in my opinion, to multiply something times itself. Okay? That just doesn't make much sense. But anyway, even if I didn't dislike squares, you know, because sometimes it works, because the two things always have to be equal. Let me think of an example. Well, I can't think of one off the top of my head. I mean, just sizing something. You could size something and there'd be a squared relationship between the volume and the circumference or something like that. So there's two causes. So you're not really squaring anything. You're really multiplying two causes that have the same value. So if you multiply two causes that have the same value, that's the same thing as squaring one of the causes. That would be the example. But that's the only point you would use this stupid thing. But obviously my point is here, there's really no reason to use a square here. There's just no reason for it. Doesn't make any sense at all. It's 9.8 meters per second. It is not 9.8 meters per second, per second, per second, per second, per second. I mean, should I make it seconds cubed in seconds? Because I can say per second 17 times. Should I make it to, you know, 9.8 meters to the 17th power? You know, or something? I mean, what the fuck? Alright, anywhere. Even though every time you throw a ball in gravity, it traces out the shape of a parabola. So again, who cares? We know why it's doing that, because it has two velocities. Okay, they're independent. This has nothing to do with this fucking squaring crap. I mean, the shape of the line doesn't mean anything. You know, in terms of, you're just saying, okay, it's horizontal. It's one direction is being affected by the other direction in the sense that it's going to be terminated by it. You know, so you can draw a funny line and say its energy over a period of time is equal to that line, but it really isn't, because it's still going to hit the ground with the same force this way, And all you're really doing is saying, I'm not even going to bother measuring its force this way, but that would be the same too. Anyway, just absolute bullshit. Alright, so that's it. I don't think there's anything else. I mean, I don't know, I'll sit and see if chatters have anything to say, but I don't know, I've been over and over and over this, so I guess I could just describe more simply what energy is. I just don't know how you don't get it. I mean, I don't know how you have some other conception of it. I can't really imagine how I ever understood energy as anything other than, a very conservative and mechanical thing. That I got the picture. Okay, I mean, I don't know if they taught Descartes necessarily, but you certainly got the impression that energy moves from one object into another object. Now, I have to say that, yes, they do explain things a little funny in the sense that they say it transforms the energy into some other form of energy. So they say that kind of stuff. And, but, I mean, to me, it was always about losing your energy. So, if something was in friction, I always understood friction was taking the energy from the object. It wasn't like, I don't even know how to describe it any other way. It wasn't some counter force trying to stop the object and push against it. I don't even know how to it wasn't something trying or forcing something to stop. It was just something touching other stuff and losing what it had by touching it. Yeah, I don't know. So, yeah, I mean, the idea that the energy is in a closed system and you just follow it. It goes somewhere. It's never not moving. And it can just be hidden because it could be moving in circles somewhere. It can move back and forth somewhere. It can be doing something I can't see. It doesn't mean it's not there. Alright, anyway. People. Hate them. Alright, so let's go find the chat crap and see what's here. So Bruce again. Alright, lifting something 2 feet is twice as much work. Okay, so there's no point in arguing this over and over again. It's about how fast you lift it. That's it. It's the amount of time it takes, and there's a ideal amount of time you take to make it the least amount of work to get to the limited location. Okay, because you don't have to stop it or you don't have extra energy. Obviously, using extra energy would be stupid. And that's the same as the free fall rate. The free fall rate is the same. So it's 9.8 meters per second. You want to defeat gravity, 9.8 meters per second of velocity over the number of seconds it would take to get to a location would be the ideal speed to use to get to any location. As lifting it 1 foot. Okay, lifting something 2 feet is twice as much work as lifting something 1 foot. No, it isn't. So there's a simple argument. Because if you lift it twice the 2 feet at the higher velocity, if you're throwing it 2 feet high, see, that's where this all goes wrong. Is you're trying to measure something based on traveling units of tiny units of distance. So you're stopping yourself from gaining anything through velocity. Velocity gives you a huge advantage, both in friction and against gravity, because it gives you less time in the gravity. So as stated, if you use the same amount of time to go 1 foot, as you use the same amount of time to go the second foot, alright, then you're right. But you're not right by Galileo, because Galileo is telling you it's 1/3. So you're gaining this huge advantage, okay, by gaining that extra bit of velocity. So you're using a little extra velocity, huge advantage. So again, you have to talk about throwing things. You can't talk about carrying things to a location in some bizarre way where you do it at a constant rate. If you lift it at a constant rate, you're doing exactly something opposite to what gravity does. Because obviously as gravity throws things down, it throws it down going faster and faster and faster because it accrues the advantage of keeping the speed it was given by the first unit of force. That's why we multiply the weight by the distance to get the amount of work. Well, I'm just saying you get the wrong answer. Okay, so I'm claiming to you overtly that every time you use MGH, you get a wrong answer. You will not predict the weight at which the thing hits the ground. You won't predict the energy it has when it hits the ground. Your prediction is a pile of shit, and you don't have a single experiment demonstrating it to be correct, because all you have to do is have it hit a spring, and you will see 4 times the distance is not 4 times the compression of the spring. That the work won't equal the energy claim. See how else to say it. It's only 2 units of gravitational energy that you acquired. You drop 4 times the distance, you only acquire 2 units of gravitational work. 2 units of work equals 19.6 in terms of your velocity. You only doubled your velocity. You only doubled the amount of work gravity gave you. There's no way you can have 4 times the energy because you only got 2 units of gravitational force affecting you. And the force, as Newton stated, is completely proportional to velocity. Or mass, if you could change masses. The speed is the rate of change. Okay, so yeah, I don't know if this is this guy here before this message retractor guy, because I'll just delete him if he's going to do that crap again. The speed is a rate of change of distance. The acceleration is rate of change of the rate of change of distance. That's why it's squared. So is this word salad or soup or whatever? What the fuck is this? This is word diarrhea. The speed is the rate of change of distance. So what? We know that's just while it's changing. Okay, so it's, again, there's no reason to square it. The acceleration is the rate of change of the rate of change. So again, that's just a lie. No, the acceleration is just the rate of change. It's not the rate of change of the rate of change. So the acceleration is just the rate at which you're changing your velocity. There's no changing your velocity twice. It's a rate. The rate is multiplied how many times did you apply the rate? How many seconds did you apply the acceleration? You have to count how many seconds. You can't just square it. Oh, I mean, I've been over this and over this and over this and over this. It's just too silly. You get 9 meters per second every second. So again, you keep saying something totally useless and redundant. Yes, I go 60 miles an hour every hour. So what? I don't say I'm going 60 miles per hour. There's absolutely no reason to do this squaring crap. There has nothing to do with reality. Again, the number is 19. Okay, after 2 seconds, the number is 19. The number is not 9.8 squared. It's 9 times 8 times 2. And if I did it 3 seconds, that's times 3. I mean, you're just so full of shit. I'm only getting 9.8 meters a second. Every second I get 9.8. What am I squaring? Why would I square anything? Come on. An example of when squaring something makes sense. Fuck this. Calculate the distance of a falling body travels in time t. You have to square the t, even though square time doesn't mean anything. You don't have to. I'm just saying that's a shortcut to getting the answer. So shortcuts don't mean they're logical. All right? Again, the fact that something has to be proportional, like 2 events are proportional, 2 causes are proportional. I can obviously square and just ignore one of the events and just say we're not going to count it because it's just going to be another cause. It's the same thing. So I can't think of that reciprocal, thank you. I mean, I can't think of a correlation to that off the top of my head. But I'm just saying that's where squaring comes in convenient. So you're just using the squaring to sit there and I don't know exactly what you're using it for, frankly. As you pointed out, I mean, the 1, 3, 5 ratio can be converted into 2, 4, 9, 15? No, somewhere I made a mistake. The acceleration, he's just going to keep doing this. The acceleration is the rate of change of velocity. So what? Okay, so that's not a big deal. I mean, I'm changing the velocity. How the fuck is that a squarable term? I'm just saying there's nothing squarable in that. Where velocity is the rate of change of distance. So again, you're just using word soup. No, the velocity is 30 miles an hour. How you measure velocity isn't velocity. So, the fact that you measure it by looking for a change in distance doesn't mean that you don't know that velocity is just a rate. It's a number. Okay. That makes acceleration the rate of change. So he's just doing it again. Why can't you see? I can't see because it's moronic. That's why I can't see it. All right. It's absolutely moronic. Okay, they're both rates. A velocity is a rate, an acceleration is a rate. I'm saying to you, why would I ever square the rate? Ever. Ever. And again, you could 1, 4, 9, 16. It doesn't mean anything. As I already pointed, I could draw it. I can draw it. I mean, how does this mean anything to you? It doesn't do more work. I mean, it's for free. I can say it over and over again. I mean, gravity creates something that's durable. So as long as you don't hit anything, you just keep gaining velocities. All right, so all it's doing is giving you a constant rate of acceleration. And so you just add up the velocity in these units of time. So the gravity pushes something, okay, 9.8. All right, so you just make it a motion this way. So it pushes at 9.8. There's no frickin' friction. No friction. Okay, so it's got 9.8 of velocity. Okay, yes, it only traveled 5.4, but yes, it's got 9.8 of velocity. So we know it's got a 5.4 in terms of the extra distance. So let's just make these 10s and 5s to just simplify. All right, so it's got 10 of velocity. All right, it only went 5 in distance. All right, so what happens in the next second? Well, it's going to get this 5 of distance from gravity. That's what it gives each second. So the only thing gravity is giving it is this 5. Right? Remember to do that. Okay, so 9.8 of force. All right, so we're just saying this is 10 for the sake of argument. All right, so it gets 10 velocity in the first second. So this is 1 second. All right, what happens in the next second? All right, the new force is only going to give it 5 in distance. So what it's going to get is another 5 in distance. All right, from the new force. But it has 10 from the previous velocity. So the previous velocity that is now not working to get anymore. I don't need to do any more work. Gravity doesn't need to do any more work. It already gave it a 10 here. So the 10 means that its velocity is 10, which is, it's going to give 2 units of this. So it's going to give you 2 units more. So you're going to have 3 here and 1 here. And you didn't do any work. Only 1 of the 3 units of distance did gravity actually do any work. So only this portion of this, right, this one piece, that's the only piece in the second, right, second 2. That's the only part of what it did, of the work done in second 2. All right, that gravity actually did work, because the rest of it was free from the first unit. And now we have this much faster velocity of 19. So, 20. Okay. So now we're going 20. So now we're going to gain even more units, 4 of those units of distance, plus 1 more unit of distance from the new second. So the seconds are only giving us this tiny, this is all we get each second. That's the only thing there's actually new work. And all the rest of it is from the previous work done. Anyway. It's only 3 seconds. It's only units of time. It's only units of weight, you could argue. I could convert it into something else maybe you could understand. But per second means in the 1 second, all you're going to get extra, okay, is this 9.8 meters per second velocity. That's it. You're not going to get anything else. It's moronic, isn't it, an argument? No, I made all these arguments. How the fuck isn't what I've stated in all these videos not a legitimate argument? It only goes twice its speed at 3/4 of the distance. How can you be talking about it being linear, okay, when the fact is that it's completely not linear? You're going half your speed. You go up against gravity. You go half your speed after you've done 3/4 of the distance. Clearly, it's not a linear thing in the sense that obviously you're getting rid of velocity at a very uneven rate. You don't square the rate. Well, obviously, if you put the square on the rate, it's squared, okay? 9.8 meters per second squared is squaring 9.8 meters, retard. So if you're going to write per second using the squared symbol, it has a consequence, fuckhead. God damn it. You recognize that it's a rate of change of again, I will not discuss a rate of change of a rate of change. It's baby talk. It's just so moronic. The rate of change cannot be a rate of change of a rate of change of a rate of change. Okay? It's just a rate of change. It can only change the rate one way at any one moment in time. It can't change the rate like, let's go back in time and change the rate that happened yesterday. The rate is always just one rate of change. You can't rate of change of rate of change. Oh, I just can't. I mean, you have to be really way up shit for brains ass to be able to even write this kind of crap. Why would somebody even be able to write these kind of bizarre defense of this shit unless they really are up this shit's ass? I mean, they really want this shit to be the truth somehow. Second derivatives don't exist? Well, I would claim, what do I need them for? All there is in the universe is geometry. The only math that has any value or meaning is geometry. I'm just saying, if you concede my 3/4 argument, okay, that something goes half its speed at 3/4 of its travel. So whether I roll something on a surface being affected by gravity or I throw it up in the air, that the fact that it reaches half its speed, okay, 3/4 of the distance, kind of proves it's not a linear per foot force. I guess we're at an impasse. No, we're at a point where you won't concede you really should have evidence. If you're going to say for 350 years it takes 4 times more fuel to go twice as fast, you should have fucking created a little bit of evidence. Something. You have 0 evidence, okay, for your fucking theory. And it's a theory where you're claiming Newton, Descartes, and Galileo were too stupid to see it. We've both heard each other's arguments and aren't swayed by them. you're not conceding the argument. That's the truth of it. You won't concede any of the facts stated. Is it a fact that you don't have evidence? Physical evidence. You're making a bold claim that should be easily proven, and yet you have no physical fucking evidence. You've never even bothered to see how much fuel it takes to make something go twice as fast. You've never even bothered. You haven't made a lever experiment. You haven't done any experiments. None. And you're claiming all of this shit. And you are claiming you can violate conservation of momentum. It doesn't matter what you say. The force is the mass times g. The point is it's a per second force. The g is a per second rate. The constant is per second. The car can't understand what acceleration is. Yeah, sorry. I can't understand why I would square it. Why changing a velocity is a squared term and a velocity is not a squared term. Why would acceleration be a squared term? Why? It's just a change in velocity. I changed the velocity. So what? What's the big deal? Why is it 9.8 meters per second of acceleration, per second, and velocity is only per second? Why would I square acceleration? He's pointing it to me, okay? It's kind of obvious. I mean, all you people think acceleration is something special. I'm saying no, it's just an event like any other event. So what? There's no reason to square the event. It's a single cause of a single effect. I have no reason to multiply the cause times the effect. Maybe it would help to hear your definition of speed compared to acceleration. I think that's just more baby talk. Why should I talk about speed and velocity as being different concepts? It's just stupid. Speed is in no direction. How the fuck do I make a speed in no direction? So it's just silly. Fuck you. Velocity and speed are exactly the same fucking thing. There's no fucking other. There's wet and there's wet. There's no point in making up these fake extra words. There's no such thing as speed in no direction. In all directions. The difference is they're both just rates, okay? I don't know. How do I... Velocity versus a change in velocity. So it's like saying something's ticking 9 times a second, and I change its rate, okay? The times it's ticking to 4 times a second. So what? I changed it. So what? Why would I square the changing? They're just rates. So if I change it by 4 seconds every second, if I make the event happen every second, well, I have to count how many seconds it happened. I can't square anything. Squaring anything isn't going to give me the answer. if I throw a fishing line into the water once, okay, and I have a certain likelihood of catching a fish, and I throw it twice or I throw it 3 times, I can't, there's no point in squaring anything. I have to count how many times I rolled the dice. If there's a probability of rolling snake eyes on the dice, I have to roll the dice, and I have to count how many times I rolled the dice to find out what the probability is. So, there's nothing squared. Doesn't matter whether you measure it. It doesn't matter what you measure distance in. Again, you just keep claiming that this is about 9.8 meters per foot. It's already known it's not per foot. It's per second. So I don't know what meters has to do with it. You measure acceleration, exactly the same thing. There's no difference. You're measuring a change in its velocity. You're just measuring a velocity and then remeasuring a velocity and saying this is how much the velocity changed. The velocity is the only thing that's real. The acceleration isn't a real thing in the sense that it's an event. It isn't a thing. The velocity going from point A to point B is the real thing. Motion is the real thing. And all you're saying is I changed the motion. Why would I square the change? I changed it once. Why should I say it's anything squared? If I change it twice, then it's twice. If I change it 3 times, then it's 3 times. I multiply it by how many times I change it. I don't square anything. No, okay. I'm just saying that from my perspective, every time you square something, there's a deception because you're really using 2 different causes, and because the 2 causes are related to each other, that is, they're linear, proportional, you can get away with it. I'm saying, yes, I don't see any reason to square anything, except to square. The geometry again, back to geometry. Yes, squaring a square, okay, to get the volume makes perfectly good sense. But you're not really squaring, right? You're really multiplying a height times a width, length. You're really multiplying 2 different numbers, but because the 2 numbers are perfectly proportional, you can get away with squaring. They're the same number, so yeah, it works. But that's why it works, is because it's a square, not a rectangle. How can the speed of light be squared? Well, that's made up, okay? I'm sorry, but it's just a made-up number. Einstein knew there was a hell of a lot of energy, and he just said, what's a preposterously big number? And so, yes, the speed of light squared is a preposterously big number, so that'll work. Because who's going to have a scale to measure it? The actual truth. Obviously, I'm saying a mass, electrons and protons, have no energy, okay? It's only the force they collect that gives them energy. So they don't have any innate energy. So the whole MC squared thing is bullshit anyway. The fact is that atoms have a lot of energy stored in them. They have a lot of force trapped between the electrons and protons. And it's that energy that you are measuring, okay? So it's really the mass of an atom, because when you get to the actual electrons, they don't have any energy innately. But yes, there's no reason to square time. Anything that's squaring a timed event is time isn't a square. Time doesn't have a volume. Time isn't 3-dimensional. How many ways can you say it? Tell me this stuff that's in the 3 dimensions that are, by the way, perpendicular to each other, making squares. You can get away with this crap. But things that aren't 3-dimensional, you can't get away with it. Things that aren't 2-dimensional, you can't get away with it. There's no... Time is 1-dimensional. But the more important word here is you should know it just from the idea of rates. There's no reason to square a rate. Let's see. Wouldn't 3 miles per hour squared imply that miles are now square miles? I don't know what it would imply. I'm just saying that there's no reason to do it. There's no place that could work in the universe. I'm just saying squaring a time just doesn't make much sense. So anytime you're doing it, it's a trick. There's some other variable you've excluded because it's somehow directly proportional to the time number. Well, no, it's directly equal to. Let's see. Except we know a ball will fall 5 meters in 1 second, 20 meters in 2 seconds. And how is that an exception? In general, it falls 5t squared meters in t seconds. 5t square meters in 1 second. How could it 5t? I don't know what time, squared, 5t squared in 1 second. It obviously doesn't fall that in 1 second. In t seconds. So again, you're saying in t seconds. So what the fuck? I don't even know what you're saying. Of course, it's a number of seconds. I don't know. You're saying it's you can't multiply. You can't do both those multiplications and get anything called a rational answer. So if you do 5 squared and then multiply it by how many times it actually did happen, you're not going to get the right answer. That's like squaring 9.8 and then say times 4 seconds. So I square 9.8 and get whatever the number is, 100. And then I multiply 100 times how many seconds it happened. Why would I do that? I know I'm not going to get a right answer. It's not going to be going that fast. Let's see, I agree that squaring a time doesn't mean anything. Okay, the distance it falls is 5t times t meters. Well, again, I don't believe that. So whatever, I don't know what this is. 5 times t meters. Alright, well, you're just going to do math at each other. That's your business. You're squaring the time again in that formula. Okay. Yes, and it gets the right answer. Inconvenient, isn't it? So he wants to play this game. Because there's a relationship between you can predict where it'll be after 5 seconds. And so it's kind of obvious, right? You do 1, and then it's 4, right? And then it's 9 in distance, because each unit is accruing, so you just keep growing on that line. So the fact that you can draw that line doesn't mean anything. Doesn't change the fact that it isn't any more than you're going 9.8 meters per second in the first second, and in the second second you're only going 19. Okay, 20. And in the third second you're going 30. In the fourth second you're going 40. It doesn't change any of those facts. Work out a few examples to confirm. Let's see what that doesn't mean anything. It's on the board there. Whatever. 5 meters in the first second, 10 plus 5 in the second setter, etc. Yeah, and that's exactly my argument. You didn't pay for the 10. All you're getting is the plus 5, plus 5, plus 5, plus 5. And all the extra distance is being created by something not doing any work. You're given the initial velocity of 5. That just stays. The second, you're giving another 5. Well, 10 is the right answer, but I mean, you're only getting 5 in distance. Okay, but you're getting 10 in velocity. So in the first one, you're doing this much distance. In the second, you're doing this gigantic pile of distance, but you only put in 1 unit of energy. That's the part you're just ignoring. It's only 2 units of energy. 2 seconds is 2 units of energy. And it's only twice the velocity, and it's only twice the weight, and it's only twice the energy. Per time at Bruce Lefty. Does that really make sense to you? He just won't take a consequence for his squared term. If it's 9.8 meters per second squared, then it's 9.8 meters squared. You can't solve that equation by doing anything other than just multiplying 9.8 times 9.8. It certainly is a force times time in gravity. So there's no doubt about it, because we know how that force works. 9.8 meters per second. We know how the force is being applied. It's in seconds. So of course it has to be in units of time. Force times time. If it was in per foot or per ounce or in some other unit, well, then you would be multiplying by that unit. Okay, that would be the unit of the momentum. The force would be in a different unit. I mean, I suppose you could theoretically go by some kind of known idea of weight and how that affects energy in terms of atoms. And you could understand it and state that the weight does equal, force would be times weight. Because you've established that the mass of an arrangement of electrons and protons, whenever you put electrons and protons together, they will collect a proportional amount of, you could say an average amount of energy. And you could use that average number. I'm just saying there's no point in saying that force is only one equation, because force comes, although it's elementally all the same thing, there's a difference between being hit by the raw force and being hit by an object carrying force. Because obviously if I'm hit by an object carrying force, I have to communicate with that object to take or lose force to it. Where if the force hits me directly, then it's a much easier calculation. And it's always just going to be a unit of time if the force is consistent. I mean, the amount of photons coming off the sun ends up being pretty consistent, right? So you can just sit there and say in a certain unit of a certain amount of time, a certain number of photons are going to hit you. There's just no way to fuck that up. Again, the paint sprayer and the rain analogies are rock solid. I don't know how you've in any way put any dent in those analogies at all. But you're essentially collecting gravity. And you collect it at a rate. And so, depending on how much time you're in, I want to know how many photons hit my hand. I just measure how much time my hand was exposed to the photons. There, that's it. Exposed, not exposed. Exposed, not exposed. I just count how much time. And I know how many photons hit, because the photons are coming at a rate. I mean, do you believe in squared sunburn? Sunburn squared? The photons are coming at, 3 photons per millisecond per meter. So somehow we're going to argue that I should square that number. and pretend there's more photons coming than are? Meters per second is distance per second. Well, okay. But we know that distance in this case is a rate of increase in distance. So it's meters second seconds equals speed per second. Well, no, that's not true. So I don't know what that means. Equals distance per every second. Distance per every second. Dividing meters per second by seconds. Why would I do that? So now it's just, I don't know, now you're adding another seconds. I don't know why I bother with that. Anyway, the paint spray analogy is really good. Yeah, in my opinion, it's decisive. It perfectly illustrates what's happening. You're collecting gravity, okay, and you collect it at a timed rate. I mean, it's so fucking obvious that it's not 4 times the force in 2 seconds. It's only twice the amount of force you collected. It's easy to understand. The longer you are in gravity, the longer you will be hit by the paint. Yes, the more force you collect. It's all about time, and it's all about collecting, and the only thing there is are you giving some of it back away? So I can change how you travel in the force by putting you on a ramp. But what's the ramp doing? It's converting the gravity into heat and vibrations and all of that kind of crap. So it's just absorbing all the extra time you put the object in the gravity. You're just absorbing all the extra units of force by vibrating a ramp. The units of acceleration and speed are the same. It's a rate. Acceleration is just changing the rate of velocity. So again, it's just sitting there saying the rate of the velocity changed. It's not some magical thing. It's not anything. It's just saying I'm changing the rate that the event is happening. How is changing the rate that the event is happening meaningful? I mean, in any way that requires you to square something. Rate means per second. I don't know that. I don't know if that's what it means. I'm just saying a rate is a a number over a number. A rate is it's 2 causes, right? It's 2 factors. I guess that would be it. There's 2 factors. The rate is a prediction, right? So it's basically telling you this is how much of something will happen in a fixed amount of something else. So I have a fixed amount of something else, and I'm just telling you how much of this will happen in that fixed amount of something else. Oh, people give me a headache. All right. Yeah, rate means per second. I don't know. Again, I don't know what that means, frankly. I mean, would you do that to a frequency? I mean, I don't. I mean, everything doesn't have to be per second. So I mean, there could be rates that aren't rates per second. That are actually rates per amount of distance. Analogy: velocity is just a rate. It's a rate of change of distance. Oh, I hate that. It's a change in the velocity. It's not a change in anything called distance. Velocity is not a distance. It's a rate at which you are covering distance. It's not made out of distance. Their velocity is distance, and distance are the same thing. So that's where, yes, you've gone completely out of the ballpark of being fair. Okay, those are not synonyms. They're not. The fact that the fact is you will measure the change by measuring distance doesn't mean velocity is distance. It isn't. Velocity is a rate at which you cover distance. It is not distance itself. One is just a rate. They're clearly wrong, right? That's clearly wrong, right? Yes, that's clearly wrong. Okay, similar, you're saying that velocity and acceleration are the same. No, I'm saying the only thing that is the real thing is the velocity. The acceleration is a change in a velocity. It, again, isn't a velocity itself. It isn't a substance itself. It's a change in a substance. It's a change in something real. Are the same because one is a rate is just as wrong. Let's see. Similarly, you saying that velocity and acceleration are the same. I'm saying the only thing that's real is the velocity. The acceleration is a change in velocity. It's not velocity itself. Because one is a rate is just as wrong. Let's see. Are the same because one is a rate is just as wrong. They're both rates. They both can be rates. I mean, obviously, it has to be a consistent thing. The acceleration has to be a constant acceleration to be a rate of acceleration. Velocity is the real thing. Velocity is the constant thing that you have to break with some counterforce. So obviously, in all these cases, we're not talking about some counterforce. So what's the unit of acceleration then? The unit of velocity is meters per second. Well, since you're changing something that's in meters per second, obviously the velocity, the acceleration is just a change in meters per second. But it's still a change in the velocity. It's not a change in anything else. It just changes velocity. It's not a distance. An acceleration isn't a distance. An acceleration is a change in the rate at which you're moving a distance. The real idea is one thing is a real physical phenomenon and the other one isn't. In the sense that the velocity is the underlying real thing. The acceleration, again, is just a change in that real thing. What is a second squared? What does that mean physically? It can't mean anything physically. Obviously, you're not squaring the second, you're squaring the 9.8. So that's the problem with their whole theory. Is mathematically it says square 9.8. It doesn't say anything else. For me to write 9.8 seconds per squared is to say 9.8 squared. It's not saying anything else. You can say it's just a way of saying, but you're putting the squared term. You're using a real mathematical power symbol thing. Okay, it's not semantics. When you put that square on there, there's no semantics that says, it's the same thing. It's not the same thing. It's a huge difference. 10 and 100 are completely different numbers. Again, let's just recognize the context. They have, in 350 years, provided zero evidence, really. I mean, there's nothing. That this theory has anything to do with reality, that this fake energy has anything to do with being anything real. They can't explain how it works in space in terms of it doesn't equate to thrust at all. It makes no sense at all, okay, because spaceships don't obey these kinetic energy rules. And yet they sit there and just keep convoluting, come up with excuses why it's right, and all of this little mushy way, and they'll never do it in any kind of real way. They'll never substantiate it by actually showing the 5-ton train making twice as much electricity as the 10-ton train, going half the speed. They'll never show any of this crap. I understand that what does a second squared mean? I keep saying it. They're squaring a number. They're not squaring a second. What does squared time mean physically? Yeah, it doesn't. They won't answer that question. Because it can't mean anything physically, because time is one-dimensional. So. They're saying that something else that time is related to, which is now their word distance, that's three-dimensional and that I can square. So they're just equating time with distance somehow. But I'm just saying what they're explicitly writing as math is explicitly getting wrong answers. Alright, velocity is measured in meters per second and time is measured in seconds. When you divide velocity by time, you get meters per second per second. Why would I divide a velocity by time? So I could ask that one. Why would I do that? That's almost like saying I have an unvelocity. Right? I mean, you can understand multiplying velocity times the number of times you did the velocities. Well, I can't even do that. I can't really even understand how you can multiply a velocity. You have to multiply the velocity as a rate. Alright, anyway. But why would I divide? Your meters per second, which is the same as meters per second squared. Well, I would look at it exactly the opposite, right? If I have a t in the top of a fraction and I have a t in the bottom of the fraction, I'm just going to cross those two t's out. So, no, I don't accept your idea that I square them. Alright, but you can calculate how something falls in gravity in a time by squaring. Well, again, you're saying you can predict how far it will travel. And I'm just saying that's a trick. Okay, that's fine. You can do that trick, okay, in terms of taking advantage of the odd number thing. But it doesn't mean anything. I mean, I'm not good enough at geometry and math to sit there and draw you that picture, but I'm just saying to you, obviously it has nothing to do with the energy in, because the energy in is only the same tiny unit of extra that you're adding each time. You're only adding 5 meters. Each second you're only adding 5 meters of real distance. The rest of the distance is all acquired velocity. How much distance change per second? How much distance change per second equals meters per second. So again, this is how you calculate a speed doesn't mean the speed is made out of what you're using to calculate it. Velocity isn't distance. How much velocity change per second? I don't know, equals VS. See? No, I don't see. But whatever. You argue among yourselves. Sorry. You don't acquire the force of gravity per distance. You acquire it per time. Now that simple statement, okay, is the one you have to attack. That's the statement you have to prove is wrong. And I'm saying I've already debunked you in the sense that Galileo debunked you. Because clearly you go 3 units of distance and you're only going half the speed, which means you're losing energy non-linearly. Okay? You're losing it not by distance, but you're losing it by time. The first second you lose only 9.8. In the second you only lose 9.8. Gravity is clearly a time-dependent force. So, I mean, that statement, how do you turn it into, no, it's a distant-dependent force? That's all I'm saying. I mean, it just seems kind of obvious it's a time-dependent force. Completely controlled by how long you're in it. Will decide is the easiest way to calculate how much of it's going to affect you. Because it is, in fact, a rate. And it's not change over distance, it's change over time. That's why you need to divide velocity by time. It's a rate. You have no time. You're using 2 different times. Don't you? You can't even see that part? That the time you're using to decide the rate is 1 full unit. The time you're dividing by is some other unit of time. It's another amount of time. It's a different number. How can you call it a squared term when the 2 times are different times? They're not the same number. You can't square something that's not the same number. But you wouldn't do it anyway. I mean, there's no reason to contrive your fake fraction. I have a number, a rate. Why would I put the rate under a fraction? I mean, over a fraction. Why would I do that? There's no reason to do that. So they just want to argue their math tricks. And they don't want to really answer the question. They don't want to attack the actual fact. So again, I can argue that it's clear that gravity is a time-dependent force. Comes in units of time. It hits you in units of time. And it doesn't give a damn about how much of this you do. You can squiggle around and move all you want, and you will not change how much gravity is affecting the object per unit of time. Your motion is irrelevant, except when you're opposing it, or it's being added to your velocity. Okay, gravity is a force. It comes in units of acceleration. Now, it comes in units of energy, a number of photons. It comes in an amount of something. It doesn't come in an amount of change. It comes in an amount, of actual motion. Due to gravity. Well, again, he's just writing the same shit again. So, there's no point. So you have zero evidence, and you have mathematical contrivances, and I have the paint analogy. Okay, and I have the rain and bucket analogy that perfectly duplicate what gravity does. Perfectly explain why it's twice the velocity, twice the weight, twice the time. It's not for anything. So again, I can only keep saying it. You people aren't stupid, okay? Like, accidentally. You're really working at it. You're trying to be dumb. I mean, if I was making an argument for which I had 300 years to do simple experiments to prove, and I never did them, I wouldn't be saying I'm a great scientist, okay? Just like the Eddington experiment, right? You're going to say something's true. Okay, gravity bends light twice as much. And you're unwilling to prove it, okay, even though the experiment is almost nothing from space. That's not good science. I don't know how you feel good about yourselves, like you're arguing from some good position. You're just religious kooks who want to sit there and try to bend people into your religion. You're proselytizing for nonsense because you clearly don't have the integrity to prove it before you assert it. Let's see, what does it mean to say that gravity comes in units of time? It's just so obvious. It means exactly the same thing as a paint sprayer coming in units of time. The amount of time you're in the spray will decide how much paint hits you. So that's what it means. How's the gravity today? I don't know what that means. Oh, about 45 seconds? 4.5 seconds. I don't know what that means. So whatever your witticism is, it fell on my deaf ears. Paint sprayers come in units of liters. Oh, no, they don't. It's about how long you're spraying will decide how much paint you put on a surface. Undeniable fact. The rate that it sprays is consistent. It sprays at a rate. Okay, it doesn't matter whether there's a gallon of paint in the bucket, or it doesn't matter how much paint you're spraying. It's the rate at which the spray is coming out of the nozzle. Alright, of paint per square meter per second or some such. Well, I don't know what that was, but that was obviously crap as a counter argument. They come in whatever, cubic something meters or something, I guess. I don't know what that is. CFMs. I've sprayed enough paint to know. You push the little button and a certain amount of paint comes out at a pretty consistent rate. Okay, and all that matters is more paint, I hold the button longer, less paint, hold the button less. I mean, fuck. You have to pervert everything. So let's just go back to the rain analogy. It's raining. It's raining at a constant rate. Nice, steady rain. Okay? And gravity's doing exactly the same thing. And I just put a bucket out and I say, how much rain am I going to collect? Well, the longer the bucket's out, the more rain it'll collect. The less bucket's out, the less rain it collects. Gravity's doing the same thing. I mean, photons from the sun. All right, let's just stick with the photon argument. I'm going to expose my hand to the light. What's going to matter? Oh, that's right, how long I have it exposed to the light. That's going to decide how much I collect. The change in the analogy would be is that obviously we're not measuring, photons hitting a surface. We're measuring a force that's giving something a velocity. But the more exposure, the more velocity. And also we can drain, the velocity from the object by hitting it with something else like air. Well, I shouldn't have to. I don't really have to come up with other analogies. I mean, I've already made the point. They have no physical evidence. They have contrived math, and that's it. Math of dubious reasonableness. And let's see. And yet they're completely confident that gravity can be measured based on distance. That it's a linear relationship between the distance you travel and how much energy you'll have. I looked it up. CPM, or cubic feet per minute, is the unit of airflow used in HVAC calculation. Yeah, well, who cares? I mean, the point is it's time related, okay? The minute part. Could be seconds, could be milliseconds, could be billionths of a second. Doesn't matter. It's a unit of time. Oh, fuck people. It's a rate. God damn. I mean, theoretically, you could calculate that into, you could actually do the calculation. You could get the number, the CPM number, and you could just calculate it into one element of paint, one particulate of paint per, whatever, 0.000000000 seconds. Alrighty then, I guess that'll be it. So, didn't get anywhere as usual. And, I mean, until we have some really good experiments, I guess, we're just stuck. So until somebody does the, 4 times the fuel to go twice as fast experiment, or somebody does the, all these lever experiments, all these things, they really aren't that difficult. So it should be somebody who can make a, manufacture a decent version of the experiment and, show us the truth. Let's remember, Brozo was supposed to do that over a month ago. He had a decisive proof, a perfect 1.4 result for a lever. No, never saw that. So anyway, yeah, well, he got rich or something, and I don't know what happened. He inherited some money. I don't know, something. Who knows? I don't go researching all of his posts somewhere, but something is distracting him currently. Can you propose an experiment to show 4 times the fuel for 2x the speed that you would accept? Well, just show me something that looks a little bit like it. Link me to something. Yeah, well, as he pointed out, it's not that much fun getting fake teeth, and fake teeth don't all work that well. I think, Warbles on a lot have to have all his teeth pulled out for his cancer therapy, and which is just, I can't even imagine the horror. Frankly, teeth are such a bitch. But anyway. He got a set of falsies, and he doesn't use them, I don't think. She can't talk with them. They make them so, they ought to just make them so they're sort of like you have talking teeth and then you have chewing teeth. They ought to make it 2 versions, because you can't talk with chewing teeth. But yeah, see, they got all this technology now. They can make all this shit out of hard plastics and, really good stuff. But they just make it so big and clunky, that you stick it in your mouth and you can't talk. If it were true, if that were true, people would be driving so slow they would save so much money. Yeah, well, I'm just saying it's obviously not true. And that's why we don't see any evidence of it. It's just the good reason for the no evidence to exist is because something isn't true. Just like light being twice as bent by gravity. All this easy experiment to do to prove it. So why doesn't the experiment exist? Well, because it doesn't work. And they don't want to say that. I mean, a NASA scientist did point that out. I mean, a guy who worked in lasers at NASA for 20 years. That, NASA's never seen light bending outside the corona of the sun, the lamb of the sun. So without the dirty bits to bend the light, there is no light bending. I'm just saying that 4 times is huge, okay? It's not like it's a little difference. 4 times 2, I mean, it's twice as much fucking goddamn energy, okay? So it doesn't matter how you could have huge inefficiencies in the goddamn experiment. You should get some indication of it. So yes, you can make all kinds of excuses. I don't care whether you're accelerating, okay? We just show it the acceleration part, or we just show the driving part. You should get some indication of it. Twice as much energy, twice as much fuel is a big amount of fuel. Okay, it's not a small amount of fuel, it's a gigantic amount of fuel. A constant speed isn't that bad because it's a constant amount of wind and a constant hills up and down. All that stuff is a constant in a way. So it's braking that's the real problem. So you can't do the experiment with a lot of differential braking. But outside of you doing a lot of braking, okay, there's not a lot of places where the experiment goes completely south. Because most of the other stuff that's going to happen are going to be relatively consistent. So as long as you're not going 100 miles an hour and end up getting to some kind of terminal velocity problem, the air resistance and everything else isn't going to be that dramatically different. I mean, it's different, but it's not going to be dramatic enough to use up half the fuel. If I want to hit the ground at twice the speed when jumping off a building, I have to climb 4 times as many stairs. So again, you're just ignoring the whole point of the argument, which is accruing a velocity. That is, it puts in the force and it maintains the freedom of that force. The first push, and then all the other pushes add. You're not adding when you're walking up the stairs. When you're walking up the stairs, you keep taking away and starting from 0 again. You don't have any added benefits or liabilities. It takes me 4 times as much energy to do that. Yes, I'm just saying that it's not the same thing, obviously. We're talking, the only rational way to do this is to compare lifting to lifting. I mean, launching to launching, launching to falling. You can't compare, well, I lifted it 1 foot and then 3 days later I lifted another foot and then 4 days later I lifted another foot. It's not the same thing. You are saying it doesn't take 4 times more work to get to the 4th floor. I'm saying if you launch the object, no, it won't take you 4 times the force. So if you launch the object to the location, you'll do it with the same energy you're going to get back when it falls. I mean, you're really apple and oranging the situation. I've said it before. I mean, I can make this infinitely heavy. I mean, I can use an infinite amount of energy to lift this a foot. I can just sit here forever and just keep holding it against gravity and keep doing work. So yeah, I can slow the process down so much that I steal all of the velocity advantages. I lift at so little velocity that all the accrued velocity advantages disappear. It's like the rolling ball on a track thing, right? Where it goes up and down, up and down. I can destroy all the extra energy I get by dropping the ball further okay, by just having a whole bunch of loops. And eventually I'll end up going slower than I would have gone the straight line. I mean, there's lots of ways you can, gimmick up the experiment, but the simple truth is gravity gives, you fight what you get. I mean, you get what you put into gravity, you'll get back again from gravity. It's the same thing. So obviously the most efficient way to launch something is to launch it at what would have been its free fall velocity, its landing free fall velocity. Oh yeah, let's stick to, well, fuck you. Anyway, I'm not launching myself up the stairs. I know, I'm saying that you're not doing the same experiment. It's not the same experiment. So yes, you want to do it inefficiently, put more stairs on the staircase. You want to make it even more difficult, put more stairs on the staircase. Go sideways, have walkways and all kinds of, do a lot of sideways motion. You can make it even more work. The fact that you can make a simple task harder isn't a law of physics. That no, there's no way you can do that. There's no law in physics says you can't do it the hard way. Yeah, no, you can do it the hard way. The least efficient way. You can find a even less efficient way to do it. No law against that, but it has nothing to do with making a fair comparison. Let's stick to the definition of work that we can agree on. Well, fuck you. I mean, just fuck you. Obviously, we don't agree on it. It's force times distance. Fuck you. So that's already been argued. Especially not for gravity. There's no fucking force times distance. It's just absolute nonsense, lie, fable nonsense. Holding a pen still doesn't do work on the pen. So it's just a lie. I bet it does. I bet you can measure the work. I bet you could put a scale right there and measure that it's constantly creating a pressure on my finger. Constantly putting a pressure on the pen. I mean, you're just you don't get any of the physical arguments. I mean, gravity is a downward force. It's net down. Yeah, you don't look like you're net falling, but you are. Gravity does it first. Gravity pushes you in. The earth has to push you back to nothing. Okay? It's always work going in. In is the work. It's constantly working. Alright, waiting millions of years for dinosaurs to turn into gasoline isn't the most efficient way of getting speed either. I don't know what this has to do with anything. And obviously it's not dinosaurs, it's plants actually. The dinosaur part is sort of a fable. The dinosaurs decomposed pretty well in the environment. It's the plants that didn't decompose very well. Why is gasoline input okay for your experiment, but climbing stairs isn't? I just explained why. It's not the same experiment. Even if I did it with gasoline, it wouldn't be the same experiment. Why would I do it the hardest way possible, going upstairs? So again, you have to compare falling to launching. You can't compare falling to climbing. They're not the same thing. I mean, climbing up the gravitational rope or something. I mean, it's just, you can't see the difference between climbing a rope and just letting go and falling. So, sorry. I'm sorry you can't see that difference, but there's a huge difference. And the simple fact is if I put you on a lever and I launch you with much less force, then it will take you to climb those stairs. The fact is you'll get there with a lot less energy being put in. The input energy go way down if I launch you. But we can't agree on the fuel it takes to launch something to 4 times the height. Well, launch is the key word. So if you agree with launch, then we will agree in the sense that I don't think you can pretend that something other than an amount of weight will do it. And I'm going to hit the scale. I'm going to hit this side with a certain amount of weight, right? So if my velocity is 4 times, twice. I mean, if I have twice the velocity, I could understand that as being a weight. on the other side. So if I want to, shoot me up, I just put the same weight on the other side that I landed with on this side. And I can do that with a twice this heavy object. I just drop a twice as heavy object from 1/4 of the distance, and I will launch you back up in gravity. And you'll land with the same weight, okay? It's only twice the weight. I'm just saying, you're saying something lands with 4 times the weight. 4 times the height, 4 times the weight. Is that what you're saying? I'm just saying that obviously a lever takes care of it. So let's do that experiment. I'd say it takes 4 times the fuel, and you'll say it only takes 2x the fuel. Yeah, I'm just saying that's just what we can prove with a lever. I'm just saying a lever proves it one way or the other, right? You, in 300 fucking years, you haven't done the fucking simple experiments. A simple fucking experiment. Does the lever conserve momentum? You say it doesn't. I say, yes, it does. By necessity, it does. By law, by rules, by everything, it works. And it will show you, okay, that what you put in one side, you're going to get out on the other side. No, 4 times the height is 4 times the energy. You keep saying it. It's just absolute baby talk. It's not 4 times the weight. It's only twice the weight. I mean, you don't think weight is energy, so, I don't know what to say to you, because, weight is always energy. Everything hits something with a weight. I could duplicate my weight in gravity by just pushing something sideways, and I can duplicate it. I can make this scale move this way by putting a certain weight in terms of momentum into the scale. Now, it won't be a constant force like gravity, but it'll still be a constant. It'd still be an amount of pressure. And the scale really doesn't care, whether I'm 200 pounds moving 1 meter a second, or I'm 100 pounds moving ahead 2 meters a second. Okay, well, you can keep saying that. I'm just saying you have zero evidence. Zero. So go ahead and just keep saying it's 4 times the energy. You can keep saying it. You don't have any experimental evidence proving it. You've had 300 years to produce it, and you don't have it. You don't have it with horses and buggies. You don't have it. Like I said, 300 years you've had to produce this evidence of 4 times the energy for twice the work. And you still don't have it. I'm not going to argue your definitions. I've already pointed out your definition of energy is ludicrous. 1/2 mv squared is nonsense. It's fable. I'm just saying, it's obvious only twice the work. So you keep telling me it's 4 times the work to weigh twice as much. It isn't. It's only twice the work. It's just a fat fucking lie for you to say it's 4 times the work to lift this twice onto a scale. No, it isn't. It's only twice the work. Yeah, well, obviously, I'm arguing your definition. What do you think a formula is? It's a definition. You're defining energy as 1/2 mv squared. I'm saying, fuck, that definition is retarded. You're saying twice the weight is 4 times the energy. You're saying that. I'm not saying it. You're saying it. That's your definition, right? You've exactly said that, haven't you? Isn't that exactly what you're saying? Because we know twice the weight compresses the spring twice as much. So we know, by your definition, it's 4 times the energy. So twice the weight is 4 times the energy. What is the definition of kinetic energy? I don't know why you're chiming in with that. I mean, obviously the definition is 1/2 mv squared. Okay. Let's see. mv squared divided by 2. Okay, yeah, that's the 1/2. It's the same formula, just written differently. Kinetic energy of an object is the form of energy that it possesses due to motion. Well, that's not terribly interesting either. That's a lie, frankly. That's the definition of momentum. It's not the definition of kinetic energy. It really isn't. Okay, so don't take what Bruce says seriously, in the sense that just understand that's what they say, but clearly that's the definition of momentum. Momentum. That's the MV part. It's not the half and the squared part of the silly added crapola. Yes, it was hard to breathe. I thought, yes. There's a lot of smoke from Canada. Yes. Yeah, it was really bad. It's really bad here still. It is bizarre. I mean, I have to say, in my life experience here on the East Coast, I have never seen such a thing. I was actually at a couple of forest fires out west. We traveled the country a couple of times, and once, and it was almost worse, than being a few miles from a forest fire. It's really bad. And they're saying it's really weird that much smoke is trapped in these layers of the atmosphere. But yeah, it's really smells like the town's on fire. Oh, what's the definition of energy? Explain it without using the word work. Well, it's pretty easy to explain without using the word work. Motion is not work. Energy is mass moving. That's energy. Anytime you see a mass moving, that it has what we call this potential to have an energetic interaction with another object. So this is just a silly distraction, so I'd rather people not play with this. We don't need to waste time defining. The simple thing, we've got Bruce cornered in the sense that he's saying weight, twice the weight is 4 times the energy. So that's a pretty dumb thing to say, in my opinion. So we've sort of gotten him now. So he isn't going to be able to defend that. Again, you say it doesn't have mass. Where did they show putting a photon on a scale and showing how it doesn't have any mass? When did this happen? That's rest mass. Photons never rest, so there is no such thing as zero rest mass. It's just baby talk. This is where physics just goes. I mean, this is where it proves to me just how fucking doopy and stupid you fuckers are. You're not like, again, a little bit, you make a few mistakes. You are belligerently stupid. Because to ever believe them when they said this crap about a photon, so it has momentum, yet it doesn't have any mass. How the fuck can it have a 0 mass times v and you get an answer that's a positive number? How can you do that? It's stupid. I mean, obviously photons are quanta of energy. They're quanta of mass. Okay? They are real MVs in the universe. It's just stupid to sit there and play this game that they don't have any fucking mass. They clearly have momentum. I didn't say weight. It doesn't matter. I'm saying you've said it. Okay? There's no other thing to call twice the compression of a spring except weight. Weight causes it. Weight causes springs to compress and contract. You've said overtly, okay, that when the spring is compressed twice as much, okay, there's 4 times as energy there as if it's 1 compression. That's your statement, fucker. Okay, and the fact is, weight does that exact thing. So you've basically said, yes, weight creates twice the weight, twice the fucking energy. We're not doing we're on the subject of kinetic energy, okay? We're not on the subject of fucking photons, all right? So, obviously, there's the word field. I don't know why a field would mean anything to you. If I say the word field, know what pops up in my head? Wheat or corn. There's things in the field, okay? There's not nothing in the field. The field isn't magical goo. The field isn't fucking goddamn whatever, unicorn farts. The field is a something, okay? Photons are a something, okay? Yes, they are a pattern of bits of energy, okay? And that is all they are. A frequency in a field of stuff that doesn't have a frequency. So the difference is you can have a force that comes at a frequency, or you can have a force that doesn't come at any consistent frequency. And one will be called a photon, and one will be called gravity, for example. And if I change the pattern again, then I can make magnetism. But it's just a pattern in a field of force, a field of corn. So I can go out to the cornfield and I can knock some of the corn down, and I can create patterns in the corn. Okay? Those patterns move in a direction, and then they go from point A to point B, the pattern. If I bounce up and down on a scale, okay, obviously you have to push down on the scale first to do that, but whatever. I see the needle move. Why is the weight changing? Well, because you're attempting to change your center of mass, I guess is how it's really stated. You're changing your center of mass. So if you lift your legs up, the scale gets lighter. You lift your legs, you push your legs out, down, then your center of mass is now too low, and the scale has to go down lower because you've changed where your center of mass is. If I bounce, okay, we already did that. Fields in the context of force in space. Well, again, I really don't want to do this, so I'm just not going to play with it, okay? I'm just saying that there's the definition, these words have no meaning, okay? They don't define what a force is, they don't define what a field is. It's just magical mush of some kind. I'm arguing that it's not magical mush, that it's really just all quantizable, discrete bits of stuff. And it can be understood as just bits of shit moving in the universe, the 3 dimensions that exist. And the bits move in the universe, and when they hit fucking matter, they make the matter move. I'm trying to get at what weight means. It doesn't matter. I mean, you can play a game, okay? What it means to me, obviously, is mass moving. That's it. Mass moving a velocity. You're pushing into the earth right now. You weigh your atomic weight because we've established the constant to be associated with our mass being pushed into the earth with a consistent velocity representing a number that would come out to be exactly our weight. But I could give you a velocity and have you hit the scale. So say if I weigh 100, I weigh 100 pounds. I could give you a velocity, okay? I could give you 100 pounds of velocity where it will weigh for an instant 100 pounds. So I could give, there's a correlating velocity, whatever, 10 miles an hour, some velocity that will actually give your mass your weight. You will weigh your mass. Gravity's doing that all the time. That's your momentum. Right now you have momentum towards the center of the earth, net momentum. You are in fact moving more in than you're moving out. Now, not by distance, but by force. The same amount of force has pushed you up that pushed you down. They just pushed you up and down at a different speed. Does the stiffness of the spring affect that? Affect what? We're not talking about this stiffness. We're saying a scale, okay? So we have already calibrated the spring to measure. It doesn't matter whether it's stiff or not stiff. It's already calibrated to measure the twice the weight equals twice the displacement in the spring on the scale. So it's already calibrated. So an ideal environment without air resistance, a bowling ball and a feather will fall at the same rate. Well, everybody already knows that. I mean, you should know that. You shouldn't be surprised by that. They did it on the moon. Okay, it was a ball. It was a feather and a hammer. You know, no, and they fell at the same rate. And it was rather slow because, you know, the 1/6 the gravity thing. You know, they fell kind of slow. But anyway, matter collects gravity. Gravity's a nuclear force. I mean, you know, that's the funny part too, that they don't teach in grammar school. But gravity affects the tiny bits. It doesn't affect you as a big thing. It affects all the little tiny yous. Okay, all the little itsy bitsy yous. But that's true about everything. I mean, the only universe is the universe of the small bits. That's the only universe. We're just a pattern in that universe. Mass is the carrier of energy. Energy is invisible until it has a carrier. You could argue. You can't see it till it's stuck to a piece of matter. And so when I jump on the scale to see the needle move between 100 and 300, you would say my weight actually is changing between 100 and 300 while I bounce. I'm saying you're changing the gravity, you're absorbing gravity, changing your position. So you're letting the gravity allow you to free fall. And that extra distance will affect the scale for a moment. And then that'll be over. You'll be done changing your position. Once you stop changing where your center of mass is, the scale will realize that and say, thank you very much for not bouncing up and down. The spring is just measuring how much pressure you're applying to it. Pressure is the same as weight. I know it affects the scale, but does it affect my weight? You keep saying your weight is just a measure of the pressure you're applying. You don't have any weight. I only have weight on Earth because gravity is literally still pushing me more down than I get pushed back up. I mean, not in distance, but in force. There's a differential in the amount of the force because of how it's applied over differences in time. You could almost argue gravity is time dependent in the sense that it can't move any faster or slower. But you could argue the Earth can push you back any speed. It can push you back really fast or it could push you back really slow. So you could argue that the spring constant of the Earth, its elasticity potential, is insanely high. It's an insanely stiff spring, and it can push you back very, very fast for a very short distance. Something like that. But it really has to do with the fact that only certain parts of you are moving up at any one moment, and certain parts of you are moving down at any one moment. And the net is zero. But the fact is they are, how to say it? You're still stuck with the idea that to go down further is to meet more pressure. So you're just being balanced on the Earth's pressure. But you're in a net deficit. You're in a net hole. Okay, you've bent the Earth down and it can't recover technically. How to say that better than that? I'm just saying it's this poking argument. You keep poking in and it pokes you back. You're always one ahead of ins. Over the long term, the in is average to the out, and there's more in than out. you're always in some deficit. You're in the quicksand. You climb back to the top and you're back in the quicksand and you're out, so over time you're only halfway in the quicksand. If you get my point, you're never above the quicksand. Well, I don't think you have any definition of weight, do you? I mean, do you have a definition of weight? I don't think you have one. Because you'd have to say the word momentum, in my opinion. I mean, that's the only thing that creates weight is momentum. What is the deal with the shape of the universe? So you keep changing the subject, right? So fuck you. I mean, the shape of the universe is all just made up. So if you want to really start talking about, well, what do you think the eye color of a unicorn is? Do you think the unicorns have blue eyes? I mean, you can have a conversation about crap. That's your business. Do you really think they know what the shape of the universe is? Get real. They can't even figure out what weight is. So, yeah, they don't have any chance, any hope. Why speculate about something you have absolutely no real reason to think you understand at all? Well, I mean, that's an interesting definition, but I'm just saying if I can duplicate it without using G, then isn't the definition sort of crap? I mean, I can duplicate, your weight by just putting a constant pressure on the scale, and I'm duplicating it. So what does G have to do with it? I mean, obviously it's not a G thing. It's a force thing. It's a pressure thing. It's a, it's a momentum thing. I'm not they. I'm just this guy. Well, I'm just saying you're defending their story, okay? And their story, I don't think, is one you would make up on your own. So you can say that you're just defending your notion of reality. But I would argue that, no, you're pretty much mouthing their horseshit. So, whatever you want to, you want to pretend you're some sort of independent contractor here or something, that's okay, but you're just pretending because everything you've been taught was taught by IBM, so to speak, or Bill Gates or whatever. You came out of their school. You didn't figure this out on your own. In words, weight is force due to gravity. Okay, well, I'm saying that's a nothing, meaningless mush definition. Obviously, your weight is your pressure, and pressures create weight, and momentum creates pressures. Weight is momentum. Momentum always, everything that ever hits something else always has a weight. It always weighs something. The interaction always weighs something. I'm defending my understanding of how things are. Obviously, I've been exposed to them and their theories my whole life. And I'm just saying that that's the problem, right? I had to throw them out. That's what I did 10 years ago. 10 years ago, I said, fuck it, okay? I'm going to pretend I'm going to start the fuck over, all right? I didn't even do Newton's laws. I didn't do anything. I just said, fuck it, erase everything these assholes say. And let me just look at the experiments and let me try to diagram how magnets work or diagram how this works or how that works. And as soon as I did that, it was a huge liberating experience because, you start to really see what friction is. You really see what happens when bowling balls hit pins. You start trying to figure all that out. Now, when you try to do the subatomic part, it gets a little more difficult because the experiments aren't as revealing. You don't get to see electrons really, and you don't get to see protons, and so it's hard to know where to draw the line of what's real and what's not. So that part was a lot harder. But I'm just saying that's, So if you want to tell me you're willing to do that, then I'm going to tell you that if you look at the experiments, you have no reason to believe in 1/2 mv squared. You have every reason to take Galileo, Descartes, and Newton and say they got right answers for a good reason because they had a good theory. Quantity of motion is a good idea. Everything just has a quantity of motion. Momentum. What would you do if I bought an air track and reproduced the colliding gliders experiment where 100 momentums turns into 133 in one way and 33 the other? I'd say you probably made a mistake. I mean, I can't, you know. But yeah, no, I've already pointed out why I made an air track, okay? And I found some flaws in it, in the logic and in the reasoning. Because you are introducing energy to your system, all right? To get rid of friction, you're adding a huge source of energy, this air. And any tilting of the cart, so two carts collide, do you think they don't lift up a little bit? Or do you think they might lift down a little bit? You don't think that happens? So I'm just saying this is the problem with it, is that, you know, unless you can engineer a really good air track, I mean, it has to be really heavy. Okay, the carts even have to be heavy, all right, to prevent any of that lifting. Because if any lifting happens, all of a sudden you have an exhaust, and you have a supply of energy, and you have an exhaust. So I'm just saying there's lots of reasons to be not too damn confident. And I could show you the high school teacher who did the experiment where she wasn't trying to do it, okay, and the results were perfectly consistent with momentum. So I'm just saying, I don't know how ice is going to help you, frankly. Ice is water, okay? So it's not going to help. I mean, you have to do the experiment with very large objects, you know, on very small blades or something to really get to a frictionless environment. It's not as easy as you think. Ice isn't as slippery as you think it is. It's only slippery in very specific circumstances. So nobody uses, you know, water as a layer or ice as a layer because it doesn't work. So they use gas, you know, to keep a puck above the surface. But again, you're introducing another source of energy. Pendulums are really great, so do it with pendulums. I did. Now, I should have used round objects. My flaw was I didn't use round objects because the problem with the steel hitting the steel was that the steel bars would tend to turn a little bit, and I didn't create a wire to prevent that from happening or some other. So I'm just saying you have to do the experiments carefully to get perfect results. But I'm just saying when I did a ballistic pendulum, I couldn't make the extra energy, the extra momentum. And then when the other guy did it, okay, Brozo, right? He did it without springs on the air track, and it didn't work. So do you really think springs make the difference? I mean, steel, aluminum on aluminum is supposed to be pretty elastic. Why do I need a spring? Well, who cares about this minor name calling? It's the lies that I won't accept. Somebody wants to call me an asshole, I don't give a damn. They're going to say I lied about something, or they're going to misparaphrase what I stated. Well, that's going to piss me off. He has the whole world against him, so it's understandable. Yeah, it's not that I have the whole world. I have insanely evil people against me. I mean, again, they have posted images of my sisters. They've posted my house on the internet for no reason except to attack me personally. Where the fuck is that in the realm of anything like, oh, yes, he's against the world? I don't mind being against the world. I just don't like being against fucking kooks and psychotics. People who will maliciously invade my fucking private life. So fuck you calling them the world. They're not the world. They're pieces of scum who should be in fucking jail. I've been lied about. That's the part that pisses me off. Well, look, SAG, whatever TV, you're not that interesting. You want to talk about how big the universe is? Go somewhere else. Too silly. What shape is it? I mean, I can't even go into all the, all the lies that have been stated about what I've defended or advocated for, and the distortions. I mean, they're just insidious. I mean, it goes to the whole, Holocaust crap, and then the pedophilia crap, and all this crap. These people try to pigeonhole me into being a defender of some evil thing, when no, I didn't make any such argument. I didn't defend anything. I never defended any molestation or any bigotry, ever. And it's just insidious lies, distortions, perversions, taking everything I say out of context. It's disgusting. Well, I'm just saying, look, this is the flat earth. Look, Professor Lewin called an electrical, a master's in electricity, called the guy a flat earther because he disagreed with him. I mean, this is the attitude of these arrogant, obnoxious assholes. I mean, Professor Lewin advocates for something rather bold and extraordinary, that there can actually be two different voltages in the same exact location, which is on its face an insane thing to say, right? That's like saying something weighs 200 pounds and it weighs 100 pounds. I mean, it's just idiotic almost. And yet his reaction was insanely over the top. Because yes, the fact is the guy was saying you've overlooked something and you've made a mistake, and Lewin can't accept that he's made a mistake. That's the simple truth. And so because he can't accept they made a mistake, they have to attack. And that's all that is. I mean, this guy's just saying, I believe in my scientists. I believe in the integrity of, Leibniz, because he knew what a soliton and a monad was. They don't go that far, obviously. They don't know anything about the history of the formula, why it's believed in. They know nothing, right? But they're sure it's right. And they're sure science didn't make a mistake. I mean, these are the guys at, football stadiums, tipping over cars. I mean, they're just, these are people that really obviously don't have their psychology under control. The Humphrey-Brown experiment. Yeah, okay, great. Let's find out how many people out of 100 know what a Humphrey-Brown experiment is. Shit. It's like talking about the Brozo experiment. Yeah, too fascinating. I'm finding these physics conversations interesting. That's good, but I mean, they're really not here for that purpose, but whatever. I think everybody should be interested in the truth and understanding how the reality works. And these are really important bits, frankly. And when you really want to trust science. I would have done it, right? My whole life, my father was a scientist. I had a great deal of respect. But I had to come to the conclusion that, oh shit, no, for the last 100 years, this isn't science. This is religion. They just make up a theory that barely fits the facts, and it doesn't have to have any, we don't have to prove it in any way whatsoever. We don't have to show anything. We just make up a story that is, it's no worse, it's no better than a lawyer actually using the invisible man excuse. Well, you didn't prove the invisible man didn't do it, so obviously he's a good suspect. I mean, it's lame. I was just asking, what if I demonstrated that momentum can increase in a collision. Right? I'm just saying, if let's just say somebody really credible did the experiment, okay, one of the science channels, and they did a really credible experiment, and they all repeated the experiment, and you actually did prove that you could make free momentum, then yes, I would concede the universe is it's even more insane than I thought it was, because I can't make any sense out of it. I don't know how the fuck you can possibly do that, make free energy, because why wouldn't I capitalize on it? Why wouldn't I just, look, you know what I'll do? Go ahead and prove it, and then the next day I'll write up my patent for the free energy machine, because it's so damn simple. I just repeat your experiment over and over again in a circular manner, and I've created free energy. He said he would tell me I did something wrong. Yes, that's what I did. I said I'll agree with you that if it is true that you can make free momentum, okay, then yes, the universe for me changes, and I become a capitalist, and I get really rich. They want to say squared of time or rate makes sense when it doesn't happen in real life. I want to see evidence of KE in real life. Well, again, we can just keep arguing that, but obviously they don't care about evidence, okay? On the 100th anniversary, right? I mean, the 98th anniversary of the famous Eddington experiment, they had a perfect eclipse, a 12 noon eclipse. I mean, Eddington's was a 2 in the afternoon eclipse. Not ideal at all. 2 o'clock is not a great eclipse. A 12 noon eclipse is the least amount of atmosphere to fuck up anything. It's perfect. A 12 noon eclipse over the most technically advanced country in the world, right over the middle of it, right across it almost. And they didn't repeat the experiment. And you just got to say, fuck. I mean, Eddington went all the way to Africa with a 12-foot telescope, right? And had to climb a mountain with it. He went to all that trouble to do the experiment, right? And they couldn't even just open the door on the observatory. The Mount Washington, right? They got some sort of fucking 12 noon eclipse right over the top of Mount Washington. Didn't do the experiment. You can make sense out of that? I can't. From space, you don't need a telescope, and you have 400 times better seeing. So you can see 400 times better. And it takes 5 minutes. And they haven't done it from space. You could use a 12-inch telescope from space and still have 300 times better seeing. So you could throw away 100 times of your better seeing to have a 12-inch telescope and do the experiment. And they haven't done it. That's where science loses all credibility, right? Because you're just saying, what the fuck? The most famous experiment pretty much in the history of science. And they don't repeat it when they have the perfect opportunities to repeat it. Yeah, I don't want to argue this negative momentum. There's only opposite force, okay? So you can apply a force in the opposite direction and counteract a force, but you cannot create any circumstance that creates anything called an anti-force or an unforce. You can't create unforce. So it's just silly. Negative momentum doesn't mean anything if it's unmomentum. You can't undo something else's momentum. You can only counteract it. Of course, the ones with the financing backing should test KE in a lab. Well, I'm just saying you don't even need much financial backing, right? $50,000 or something. I've offered real money. I've said, look, if some amateur can do it for $500 in a well-constructed way, I mean, not in a brozo, dirty, filthy, stinking way, I'll pay him $500. But I couldn't find anybody. And then I offered $4,000 to the applied science guy. Offered him $4,000 to do some KE experiments. didn't reply. It couldn't get me to reply to my emails. But they are too busy with their neutrinos and dark matter and quantum computers. They're too busy, lost in bullshit. So you could argue that. But I'm just saying, when do you have to really be real about the fact that they're too busy not giving a damn about evidence? Because none of this is evidenced. I mean, they all just accept claims. We done it, right? The LIGO guys just say we did it. Doesn't make much sense that they did it, but they say they did it. I don't know what a goat pee is, but anyway, but whatever. Shouldn't have pets. The guy is just denying the conversation of momentum, lol. I don't want to do the thing on ice again. I'm just saying ice only works with, heavy objects. So, you have to do the experiment on a big scale, because small scale ice just gets wet. Because motion is motion. There's no unmotion. Yes. Hey, Gary. Hey, G. Hope you're all... No, who cares about all that? Goat pee is the pee that comes out of goats. Yeah, well, whatever. I don't know why goats are in the house, but whatever. It's interesting. I rent a curling rink. I'd rent a curling rink. Yeah, I'm. Those are pretty heavy objects. So yeah, go ahead. I'm quite certain, that they'll be pretty good if they use curling dodges with, an elastic bumper on them, a spring, or, some mechanical device that creates a perfectly elastic collision as possible, that you'll get the same answer I got, which is you can't make free momentum. I don't think they freeze it until the fall. Well, then we're going to have to wait for a while for you to do the experiment. But don't you concede that these simple experiments should have been done by science by now? Again, you could do them with pendulums. You just have to do it with stop photography, a strobe light. And you'll see where all the energy goes, right? We can have a 1 mass hit a 2 mass in a pendulum. What's the big deal? Right? Somebody should be able to do that. You take a twice as heavy round, perfectly round, and 1 mass ball, and you just crash the 1 mass into the 2 mass, and you should be able to tell how far it goes. It'll tell you exactly how much energy it has. So, what's the big deal? It certainly you could do so many of these collision experiments, but most of them are going to do, right? Momentum will be perfectly conserved, right? Because every experiment on YouTube that has to do with pucks, every single one of them is a conservation of momentum experiment, right? Every single one. And what's missing is I'll crash a 1 mass into a 2 mass and I'll make free energy. That's the one that's missing. Well, that is the trick. Usually you have to do a little, you could take some, a car battery and just try to fuse a little piece of wire to the ball, weld it. So you could tie a string to the little piece or something like that. But yeah, it is tricky to figure out, obviously crazy glue is, you could just glue a little holder onto the ball and hope it's strong enough. Free momentum, not free energy. Well, whatever. I mean, same difference, I'd say, in the real universe. The MVV is constant before and after. So, whatever. You can only conserve one of the two in uneven mass experiments. So, anytime you collide uneven masses, you have to either conserve momentum or conserve kinetic energy. You can't conserve both. It's just bullshit. You won't conserve both. I mean, I'm not going to go over and over it again, just because, frankly, I showed the Professor Lewin video and I showed the clay on the cart. I shouldn't have to say much more. Well, it's enough to keep the thing going for 3 fucking hours. So yes, it's the right amount of viewers, pretty much. I mean, all you need is one, frankly, some good protagonist who's semi-reasonable. So, Bruce has been semi-reasonable, just spouting the conventional crap, and, it is my obligation to debunk that, and sometimes I do it better than other times, and, it's hard to keep the focus on the facts that to me are the most telling, And so, I can just keep describing the stuff that can't make any sense, okay? Twice the weight can't be 4 times the energy. It just can't work that way. But it is 3 hours, so it is way past my get the fuck out of here and do something constructive time. So I will get the fuck out of here and do something constructive. Oh, I didn't have the chat on. Well, no matter. I mean, it sort of matters because YouTube doesn't post things. Look at that, there's a comment. Oh, that's a different video. Of course there's a comment. Alright. Thought it was my video for a second. Misimpression. Alright, so live. We'll go there. See the number 18. Look at that. Isn't that nice? Alright. So, till the next time, and such and so forth and whatnot. Blah, 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 blah. Blah, blah.